All right, so now we are going to start talking about a topic which is called as SD-WAN. Okay, now SD-WAN in itself is one of the most important topics when it comes to the network security. Right. Reason is that this SD-WAN, rather than initially it was more like um, a topic which was for load balancing the traffic and making sure that you always have the internet connectivity. But because of companies, marketing tactics, now this is like a fad. Everybody wants to know and understand what is SD-WAN, and everybody wants to implement this setup that we have. Okay, which is absolutely correct, which is absolutely fine when it comes to the implementation. But to be honest, um, removing all the glittery stuff, SD-WAN is nothing but just simple plain old load balancing. We used to do load balancing previously to the SD-WAN as well. Okay, we used to do that. But with respect to the SD-WAN, the only advantage is that you have a lot of other options and features and functionalities just added to it. So you cannot really call them, just simple plain old load balancing. There are so many other features and functionalities that you can perform. But in a crux, if you really want to understand in a very very simplistic way what is a SD-WAN, it is just load balancing your ISP traffic. Okay, that's pretty much it. Software defined WAN is basically load balancing the traffic. Okay. Now, before we move forward, let's talk about another player in the SD-WAN space who's now recognized as the top player in Gartner's quadrant. The WAN Edge. Okay, so the WAN Edge Gartner quadrant is basically one of the we are the leaders in this particular quadrant. Okay, now the report is of 2021, as you can see over here. Reason is that the Gartner report comes up anywhere between September to November every year. Okay, so that's why we are working off, just I mean for now we are working off with the 2021, and Fortinet has been named as the leader in this particular section. Okay, now as you are aware of, Fortinet is one of the biggest and the strongest player in the security domain. Okay, it's one of the most important player in the security domain, and particularly the firewall segment. And it is not only the firewall that delivers or should I say, Fortinet is the only OEM, okay, as of now, um, that is delivering native SD-WAN. What I mean by native SD-WAN is that you do not need any additional licenses, any additional feature, or operating system, or anything, or any other device for the SD-WAN. Okay, it is inbuilt into it, so that even if you want to do this in our evaluation license, you can do that as well. So that's why I say that it is one of the only OEMs which is delivering the native SD-WAN along with advanced threat protection. Okay, so Fortinet also provides excellent quality of experience of something which is called as VoIP. Okay, so great performance when it comes to VoIP. Okay, so that's why it is being called as one of the leaders in the WAN Edge quadrant. Okay. Now, first of all, let's go ahead and understand that when we say SD-WAN, what do we mean? Okay, what exactly is an SD-WAN? Okay, see, what happens is that a lot of times we have a lot of locations, and oh sorry, we have a lot of locations where we have the connections to our branches and headquarters, and every detailed location we have the connections, right? So we can have multiple branches, like over here you can see, right? Yeah, one of the branches, then we have a data center. Okay, you will also have a headquarters. Now previously, before the SD-WAN, okay, the pre SD-WAN era, okay, used to have something which was called as MPLS. Now we still have that, and it is still part of the network, but the difference is that MPLS is like static. to give you a simplistic format of what the MPLS is, it's still the connection. You can have more than one connection between two locations. So we have the branch, okay, and we have the data center, right? Now we can see that we have two connections, okay. So if one goes down, you still have the other one, but these are static locations. These are two static locations that you have. So even if you are not using the other one, this one, you're still paying for it, okay, because the paying cost is dependent on how much it is used, and it is, you know, how exactly it is being implemented. So that, I mean, every MPLS connection that you take, it's their cost calculation is a little different as to whatever your vendor is. Okay, so now if you had multiple MPLS, let's say if you have two MPLS connections over here, you will be charging for this and you'll be getting charged for this as well. If it is still not using, you're still getting charged for that. Okay, and you need to have two connections for every location, because as I said, that if in case there is one place where you're not able to, you know, connect to it, if you do not have one, so if your interface is down, then at least you have another interface through which you will be able to connect, right? That's the whole point. So now this was the setup, you know, the pre SD-WAN era. It was the setup that you need to have at least redundant interfaces so that you can, you know, connect to the system, you can connect to the resources. That was why you needed MPLS connection. Plus, we also need to understand one thing over here, that in this particular setup that we have, right, a lot of nowadays it's the network is not just, you know, the couple of branches and a headquarters, and that's it. Companies, organizations have evolved to a place where now every company has some kind of a cloud setup everywhere, right? So they will have couple of security as a service, or some cloud environment or private cloud, something, right? So in that cases, we have to also understand that the SD-WAN should be able to, you know, get the should be able to integrate the setup, okay, should be able to, give an options or give you the facility of integrating your network with the cloud as well, right? So okay, every time. All right, let me try this again. Okay, so whenever we have this setup of the branches and the centers, right? So now, oh, come on, what's happening, guys? 1 second, let me. Yeah, so now what is happening is that when we are integrating, sorry, hold on. Okay, trying to, yeah, okay. All right. So see, now in this section, we can also see that, you know, we have the setup where we have, integrations of your cloud as well, right? So when we have integrations of the cloud, we have to check that what kind of setup these guys have. So you have Oracle, you have Office 365, you have SAP. Okay. So basically you have a cloud segment. Let's say, for example, you have a mobile segment, or, a DTE connection as well. So again, there are so many additional things coming up right now, so we have to make sure that your network is basically integrating all these things, right? So if that has to happen, you have to also make sure that your system is correctly configured. Okay, so if you have multiple applications and all of them are taking network connections, so if even one of them fails, then those applications will not work, right? But with MPLS, the problem was that if your one connection is being used, the other is going wasted, right? Now you have broadband connections, you have DTE connections, right? So your system has to work smart, not hard, right? So it has to secure the network with the MPLS, with the VPNs, the broadband. Okay, so whatever connections that you have, it should be able to integrate all that. Okay, so for example, LTE, right? So it should be able to integrate all of them. Okay, and it should be able to control that which connection should go to which particular interface, right? So all of the interfaces are being efficiently utilized, okay, lowering down the cost and making sure all interfaces are being used. Okay, so, and that's why the NSS Labs has given one of the best features to work with, the SD-WAN, with Fortinet SD-WAN. So that's how the Fortinet is able to control and secure your whole organization, okay, from the interfaces, All right, that's what the Fortinet security SD-WAN is all about. Okay. All right, so let's move on. Now see, what an irony. I want to move this forward and now it's just not. Hold on, guys. All righty. Okay. All right. So now this is the reason, a crux of the story was that, it is able to load balance the traffic. It is able to, efficiently utilize all the interfaces. It is able to understand your needs. And on the basis of those needs, it is able to send the traffic. Okay. So for example, if you're, you have a couple of connections that needs to go through, let's say VPN. Okay. So that traffic, which is matching the source, okay, which is matching the source and the destination, it will go to that particular um, interface. Okay, so that is what it basically matches. Okay, so whatever your source and destinations are, your source IP, your destination IP, okay, and it will match that. It will basically take the VPN. If it is, let's say for example, your normal general traffic, okay, so the general traffic can take the internet, the normal ISP or the VPN that you have. So now they are taking the VPN, but I'm saying you do not even need a VPN. You can have just, let's say ISP1 and you can have an ISP2. Okay, and you can use both. If you have, let's say, VoIP traffic, then you can use the ISP1, and if you have general internet traffic, then you can use the ISP2, right? So business critical traffic rerouted if current path degrades below policy thresholds. Below policy threshold meaning that you can give the policy like a service level agreement, the SLAs. Okay, so you'll say that the interface should have this much of speed, this much of latency and all that. Only then it will be accepted for, let's say, web traffic. Okay, so these kind of SLAs you can implement for business critical traffic. Business critical traffic is web traffic is anyway business critical, so that's why. Okay, non-critical traffic, again, as we said, it can take the another connection, right? So that's how you are using the SD-WAN or the multiple interfaces to load balance the traffic in such a way that efficiently it is being utilized across the network that you have. Okay, now when we say that we are load balancing, right, so it has a lot of different ways, a lot of different methods that you can use to load balance the traffic. Okay, you have one which is called as a source IP, which is default. So if you have one source IP, it will take maybe, let's say, port 1. If it is coming with a different port IP, it is taking port 2. Okay, so basically depending on what source the traffic is coming with, it is going to take up a decision of what interface to take. The next is called as the source and the destination IP, where your source IP plus destination IP, this criteria has to match. If this matches, then the interface will be taken. Then you have something which is called as the usage. So for example, let's say you want to make sure that if ISP1, which is your primary, if anybody is going above 800 Mbps, okay, it should switch over or spill over to the other interface that we have. Okay, so let's say for example, your speed is 1 Gbps. Okay, yeah, your speed is 1 Gbps, and you just want to make sure that the connection should not exceed 800. And as soon as it reaches 800, switch it over to the ISP2. That's what it basically means. Session, again, it's the same concept. The concept remains the same, but rather than having the information in the mode of Mbps or the throughput, you're basically using sessions. So these many sessions or these many, let's say 25% of the traffic should be on ISP1 and the 75% should be on ISP2. Okay, that's what basically it means. And then you have the volume. So this is throughput. Okay, in bytes. All right, so again, you have different mechanisms, and on the basis of that, you take up different methods. Now, most of the time, the one which is being used is this one, 80 to 90%. In environments and network situations, it is being used, followed by something which is called as the sessions. That's it. These two are basically used the most, and then source IP and destination IP is not really used much. If you have a entry level situation, then probably yes. But if in case you are basically handling an MNC, then in that case you will basically be using either the the usage or the spillover. Okay, or the sessions one. Now again, we won't be able to do this in the lab. Okay, because I mean there'll be, I mean we will not be able to create 800 MPS of connections and and then making it switch. So we'll be using the source IP and the destination IP. We would be able to use this to give you a demonstration of how exactly the load balancing works. Okay. All right. So give me one sec. Let me power on my lab. Just 1 second. Okay. All right. Now, see, since we are going to implement the SD-WAN now. Okay. Now, to implement the SD-WAN, we have to make a little bit change on the topology that we have. Okay. So, why do we need that change? Is because we have to, first of all, have two interfaces that can be used for the SD-WAN, right? So, what we need to do is that, in this section, we will be using Fortigate port 1. Okay, this will be our ISP 1, and then we'll be using port 2, and that will be ISP 2. It won't be an HA over here. So your Fortigate South will be acting as one of the ISPs, and your ISP 1, which is port 1, that is anywhere. It's always been an ISP for us. So if you look from the Fortigate North perspective, you have two ISPs. Okay, now we'll be using these machines to make some connections and to see whether the SD-WAN is working for us or not. Okay, so the traffic will basically go through this via this interface or via this interface. Okay, clear, all of you? Yes or no? Okay, good. So now the first thing is that we have to remove this HA. So I'll just keep it over here. Okay, so now we are going to power Fortigate North, Fortigate South, the switch, the user PC will power. For now, we are just powering on the user PC. Okay, and over here the ISP, sorry, the HA. Let's say we say ISP. Okay, and this ISP 1. So we'll keep it like this. Okay, and then we'll say duplicate, and then we are putting it over here as ISP 2. Okay, so crystal clear. All right, that we have port 2 as ISP 2, port 1 as ISP 1. Okay, and Fortigate North will basically load balance the traffic between these two. Okay, all right. Yeah, okay, let's click on this. Fortigate North, Fortigate South, and the user PC. So we have 32.5. Okay, good. And let's log in over here. Admin, admin password. Okay, get system interface, and I'm just interested in port 1. Okay, so we have okay, 0.6. Okay, now the next thing is okay, port 10. You know why? Because I'm using port 1, right? So it is including port 10 as well, because it also has port 1. Okay, anyways, so we have 192.168.0.6. Okay, so we'll open up this guy. Do we have 0.6? No. So we'll copy, paste 6. So you have to look, connect to the Fortigate South as well, right? So let's quickly check what IP do we have over here. I can see that it's, I think, not used. Okay, okay, so it's first time. So enter password, all right. and get system interface, and again same rep port 1. So we have 0.4 we have. Okay, so let's say 0.4. Now I'm not sure if this will work. Yeah, because HTTP, right? You all remember this now. So config system interface, edit port 1, and set allow access inside HTTP ping and SSH. That's it. Show and end. Config system global. Set host name FGT South. Okay, and that's it. Great. So let's try again. Config system interface, and yeah, just refresh over here. Great. So now it is also working, and this guy is also working. Now what we need to do is first is basic configuration. Let's just make sure that we have the basic configuration in place. So we have we need to configure port 2 and port 2, Fortigate North as well as Fortigate South. So we have to use a different IP segment this time. Let's take 192 to 168. No, there we already have that in the event section. So let's take 10 dot section. Okay, let's do that. So we'll go into the Fortigate North first. Okay, and I'll say config system interface, edit port 2, set IP, and 10.10.10.22/24, set allow access and ping. That's pretty much which is required, nothing else. And I say end. Okay, now let's move on to the Fortigate South. Same configuration. Port 2, set IP 10.10.10.23/24. Are you? Is it clear, all of you? Right? Yes or no? Set allow access, ping. That's it. Show and end. Okay, so execute ping. 10.10.10.22. Great. So pingables, at least we have the basic network connectivity, right? So just to give you an idea, so we have port 2 and port 2 of Fortigate North as well as South connected, and they're able to ping each other. Okay. Okay, so we have port 1 and port 2 configured over here. So let me show you. So if you go into the network section, we are into the Fortigate North. You go into the interface. All right, so we have port 1 with 0.6 and port 2 with 10.22. Okay, so we have both the interfaces up and running. Now to give you an, just we'll use the alias as well. Okay, so this is ISP1. Okay, and this is my ISP2. No, ISP2. Good, 1 and 2. So basic connectivity is done with the ISP. Okay, now we are going to create the SD-WAN. But before we do this, okay, chalo, I'll keep a little bit mystery, okay, and I'll ask you questions in the maybe next 10 or 20 minutes. Okay, so just stay razor focus over here, and just keep on looking what all the steps that I'm taking. Okay, what we have done till now, we have configured the ISP1 is we have configured ISP2. Okay, we have pinged this one from the Fortigate South as well. So let's begin this. Let's just complete the basic setup. Yeah. Okay. All right. So let's look into the network interface, and there you go. So we have ISP1, which is 0.4, and then we have ISP2. Again, let's put it in the ISP1 and 2 as well. So, you know what? Let's not put anything. So yeah, because if I say ISP1 and 2, then you guys might think, how is this ISP1 and 2? Because the topology is saying that this is ISP1 and 2. And if I say this ISP2 and 1, so that will be different. So as of now, think of this Fortigate South as your ISP. This is your ISP. You do not really care about what is Fortigate South, what needs to be done on the Fortigate South. But yes, we do need to understand that it is still us who is managing it. So we will have to configure a couple of things. Okay. What are those things? I'll let you know. Okay. For now, let's go into the Fortigate North and let's try to understand the basic setup of your SD-WAN. Okay. Now, let's go over here. Click on this SD-WAN. By default, you do not have anything. You have just this, which is the virtual WAN link. Okay. Now it is a virtual interface, but it is not having any physical interface inside. Okay. What I mean is that it will only function when you are calling a physical interface inside this. How do we do that? Click on edit. Do you see this interface member? So what you're doing over here is you're basically creating a zone. Okay. Now in this zone, this is an ISP zone or an SD-WAN zone where you will be having more than one interfaces. Okay. And those interfaces are your ISP interfaces. So if in case something goes wrong and if your one ISP goes down, you still have another ISP through which the traffic will still go. Okay. So we'll go ahead and first of all, add interface. Now we can see we don't have any entries. So we have to create entries. Now creating entries is just simple. Click on over here and then it says, okay, which interface that you want to add. So I say, I need to add SP2. Okay. And I'm using the zone this. Now this ISP2 has an IP of 10.10.10.22. Now, do you remember on Fortigate South, what IP did we configure? Configured 10.10.10.23, right? Just if in case you're having any questions, please use the link. Okay. So again, 23, I'm taking this as 23 because I need to forward the traffic to the other firewall. Okay, which is acting as an ISP for me. That's why I'm using this ISP. That's as a gateway. Okay. I click on OK. Now have you noticed one thing? If I click on create new and if I select an interface, right? It is giving me a lot of interface, but I do not see any port 1 over here. Do you know why? Can you put that in the chat box? Why I'm not getting any port 1 over here? Right. So yeah, getting the answers, yes, absolutely. Why? Because we have a policy which is already having the ISP1. Okay. So I have to first of all make sure that there is no policy which is already using port 1. Okay. And that goes in the real environment as well, that if you're trying to create an SD-WAN, you have to make sure that your interface which you're using for your ISP should not be used anywhere in the firewall policy, because if it is used, you won't be able to call it in the SD-WAN. Okay, so this is one which we have. So I have to remove this and this, delete. Okay, do we have any other? Yeah, we have one more, so let's delete this as well. There you go. So we just have one, and I think let me just remove this as well. It is anyway not required. Okay, so we do not have any firewall policies for that matter. So let's go back to the SD-WAN. Okay, now see, it says green now. It was not green earlier. It is because you are using ISP2. Okay, and it is active. That's why. So anyway, let's go over here. Click on it. Click on edit, and then I'll select my ISP1 this time. So now this time I should be able to see the interface. Yeah, there you go. See, now it says dynamic gateway, which is fine because it's on DHCP. So that's fine. Click on OK. All right, select this up. Now we have both of the interfaces inside the ASP. Those. So you can, you have 3, 4, 5 as many interfaces as you want. Okay. Do you see this ISP1 and ISP2, and they have their different gateways, right? So for this one is 23, this one is 0.1. Okay. Right. Once we do this, I'm just trying to think of any specific feature that I need to tell you right now. Yeah, so okay, so once you create this, once the SD-WAN is created, the zone is created. Okay, you have to create a route as well. Okay, because you need to have a route which should be using SD-WAN. Okay, so I'll go into the static route. Now, rather than having this static route, which is actually wrong, so I'll probably change this. Okay, I'll edit this. Okay, now this time over here, I'll say 0.0.0.0/0. That basically means anything, right? And rather than having the, you know, I'll say SD-WAN, because I cannot select ISP1 or ISP2 or any other interfaces, because I have to use the SD-WAN now. Okay, because all the load balancing and everything that needs to be done, that will be taken care by the SD-WAN, right? So I'll click on the SD-WAN now, right? See, it is not asking me for a gateway. Why? Because you remember in the SD-WAN, we have already configured the gateway. For every interface, we have a gateway, right? So that's why we need an SD-WAN, which should be pointing to the default gateway. And then you need to have an SD-WAN selected. Done, click on OK. Okay. So once you have done this, the next thing comes up as a firewall policy. Okay. So to create a firewall policy, come over here. Okay. Now we'll create a policy. So I'll just, internet policy, internet access. Now source will be port 3 for me, right? Because that's where the traffic is originating from. And outgoing will be the virtual WAN. Please remember, you have to always use the SD-WAN now. Okay. Now we have 32.5, right? So let's select this. Destination, do we have 1.1 somewhere? Uh, let's say all. Let's say all for now, because I want to show you something. So let's say all and service all. Okay. Rest keeping it same. Click on OK. Okay. So we have a policy which is using SD-WAN. Okay. All right. Now I'll show you one thing over here. Yeah. We are into the north. Okay. Now what we are going to do is, please write this command: get router info routing table details. Okay. What this is telling you is, it will basically tell you your routing table, just like we are able to see that in the web GUI. Exactly, you will be able to see it like in the CLI as well. Now this is very much similar to as you what you get in your Cisco, right? Now see this. Just focus on this. I'll give you a minute. Try to understand what this line is trying to say. Okay, I will give you a minute. Just think. Okay, all right. That's 1 minute. See what is it that it is trying to tell you? Can you put that in the chat box, all of you? What does it basically mean? Can anybody tell me? Okay, okay, right. See, 0.0, we know that this basically is a default route, which might means any IP address, and then it says 1/0, and then it says an IP address. Okay, so over here, what this guy is basically telling you is that this is your gateway. Okay, 0.1 is my gateway, and 10.23 is my gateway, right? Now, in this particular scenario, what is this? 1 by 0. That's your AD value. I hope you all know what is AD value, right? AD value is the administrative distance, right? Which we have all learned in the dynamic routing. The RIP, OSPF, EIGRP. Who knows what is AD value of OSPF and who knows the AD value of EIGRP? Can you type in the chat box? Right? So the AD value or the administrative distance is, see, by default, you have a value which is given to your static route, right? Then a value is given to your dynamic routes. Okay. So that value is called as administrative distance. On the basis of this administrative distance, your route is preferred. So your route basically depends on what AD value you have. Lower the better. Okay, lower the better. So again, over here, basically, this is just telling you that you have two routes that you can take. Now, whichever one is preferred, that will be taken. Okay. Now the question comes up. Okay, I understood this, that two interfaces we have, and if in case one goes down, we have another interfaces. And I also understand that I can use one of the interfaces, but who will decide which interface to take? Will the Fortigate decide, or will I decide, or will I have to configure this? Okay, so let's move on to this question and let's understand that what you need to do. Okay. See, once we come under the SD-WAN, right? Okay. Who decides which interface to select? This is the question, right? Now let's give the answer. Let's get the answer over here. See, this place we have the SD-WAN zone. Okay. So we know that, okay, we have a zone, and inside this zone we have two interfaces. Each interface has its own gateway. And you can also see that there is one interface which is being used or preferred, which is the ISP1, right? No traffic is basically going from ISP2. We will figure out why is that is happening. But as of now, let's try to understand why ISP1 is being taken into consideration. Now, do you see this, the performance SLA? Yeah. So you click on create new. This is the place where you tell your FortiGate firewall that if you want to prefer an interface, okay, on what mechanism or on what basis you will take that decision. Okay, so the FortiGate firewall has to take a decision on which interface it needs to prefer or it needs to select for forwarding the traffic. Okay, you are basically trying to configure that factors which is required for you to ensure that the interface is selected or preferred. Okay, see over here, let's say, let's just give it a name of performance. All right, now detection is active, as in actively it will keep on checking. Okay, I'll say ping and I'll take an IP of 4.2.2.2. Okay, so I use 4.2 to ensure that my network connectivity is up and running. Okay, now either I can say with all the SD-WAN interfaces or I can specify. So if I specify, I have to specifically select one. Either I can go with ISP1 or I can go with ISP2 or I can go with ISP both. Okay, so either I'll say specify or I can say all SD-WAN member. So I'll use this one, which is including every member. Okay, now what is the interfaces and the SLA targets? We'll talk about this a little later, but let's just for now, we'll say we have 4.2 and we are pinging and we are using both the interfaces, ISP1 and ISP2. Is it clear, all of you? Yes or no? In the chat box, please. Okay, good. Now see, as soon as you open up, sorry, you saved it up. Okay, so you can see it's by the name of performance, and you have a destination server, plus you have ISP1 and 2, but then they have question mark. I'll refresh this. As soon as I refresh, you'll see something over here. There you go. You see this? Your ISP1 is green. The green basically means that your ISP1 has the connectivity, whereas your ISP2 is down. Okay, and it also tells you that what amount of latency and what amount of packet loss is happening. Packet loss is 0%, which is great, and it should not increase to a number. Okay, anything between 0 to 3% is a good number to have when it comes to packet loss. Clear? When it comes to packet loss, okay, now this is real time situations. Okay, anything which is, hold on, 0 to 3%, okay, it is an acceptable number. If it goes 4, 5, 7, or 10, that is not acceptable, because out of 100 packets, if you're dropping 10 packets or 8 packets, okay, that means something is wrong in your network. Okay, it is not acceptable. What is acceptable is 0 to 3%. Okay, that is situation one when it comes to packet loss. Then we have something which is called as the latency. So it says 90 ms. Now, since we are in the lab environment, we can still accept this, but in a normal real-time situations, it should not be, or I should say, it should always be less than or equal to 10 ms. Okay, 91 is like unacceptable. 91 is basically a performance. It's your network is slow, basically. Okay, so when it comes to performance, it should always be between 0 to 3% packet loss, and then when it comes to latency, it should always be less than 10 ms. Anything between anything within the 10 ms range is fine, but if it is going 15, 20, 30 ms, you should check what is happening in your network. There's something wrong. Okay, now one thing is ISP1 is working, ISP2 is not working. We'll see that as well. Okay, now let me show you. Now we'll enable the SLA target. Okay. Now, what SLA target basically means is that apart from pinging 4.2, you're anyway pinging 4.2. Okay, but with that, you're also giving some criteria on the basis of which your Fortigate will make a decision on which interface to select. Okay, so now what you are trying to say over here is that your SLA or your service level agreement, that is SLA, service level agreement. Okay, it says that latency should be 5 ms. Okay, as I said, anything which is less than or equal to 10 ms, it is acceptable. So either you type in 5 or you type in 10, that is okay. Then you have something which is called as jitter. Now jitter is where you have so many small packets. Okay, so those packets, how much ms values that it should have. So if it says ms is 10, sorry, 5, okay, that's fine. Again, 5 ms is a good number, but again, considering real situations and scenarios, I should say always take up 10. Reason, because 5 ms, 2 ms, or 1 ms is, I mean, it cannot be better than that. If you have 1 ms, 2 ms, or within 5 ms, I mean, your network is actually great. If you have less than 5 ms, your network is actually working in a very efficient manner. Okay, so if that's the case, great. Okay, but if not, it is still okay till 10 ms, not above that. Okay, for the same with the jitter and the packaged threshold. See, there as of now it's 0, but as I said, 0 to 3% is a good number to have. Anything above that, if it is 5%, you should start checking. 5% of packet loss is unacceptable as per the industry standards. Okay, now you have the link status. Look, let's see, what I mean is that on the base, let's say for example, on the basis of this criteria, the latency, so let's say for example ISP1 has all of these 3 criteria in under the value which is specified. So we have 5 ms, right? So let's say your ISP1 is meeting all that criteria. Okay, now your link status says check interval is 500 ms. So every 500 ms, 500 ms is basically 5 seconds. Okay, so every 5 seconds it is going to check what interfaces you have in the SD-WAN. So your ISP1 and sorry ISP2. It is going to check both of them. All right. It says failure before active. Failure before active basically means that ISP1 will be considered a failure if 5 attempts are made, and after 5 attempts this ISP1 is not reachable. Then it will be considered as failure or inactive. Then restore link after again 5 attempts, meaning let's say for example it was inactive, okay, and then it again came back online. Once it came back online, it is not it will not instantly switch from ISP2 to ISP1. What will happen is that it will check for 5 times whether your interface is stable or not. If it is stable, then it will go and move the traffic from ISP2 to ISP1. Okay, now think of a situation. As of now it says 5 seconds, right, or 5 attempts. Failure before inactive is 5 attempts, and restore link after 5 checks. So 5 checks into 5 seconds is 25 seconds. So basically whatever happens, see, for the system, as soon as there is an interface problem, for 25 seconds this will go off, right? So that is not a good picture. Okay, so what you need to do is you have to make sure that this number should be a little less. If it is 3 or 2, that is a good number to have. Now, guys, one thing which I want to just clarify over here. When I was telling you this information, 500 ms is not 25 seconds. I'm so sorry. It is 0.5 seconds. Okay, so that is 0.5 seconds. So if it is taking 5 attempts, it is 5 into, sorry, 500 ms, or that will be 5 attempts is 2500 ms, right? So that will be the amount. So let me just check how much is the 2500 ms. Okay, so 2500 ms is how much? This will become 2.5. Sorry, I'm sometimes I get so bad in maths, although I do like maths, so please do not judge me over there. But yeah, so it will basically take 2.5 seconds to switch from ISP1 to ISP2. Okay, and a restore link after 5 checks, which means another 2.5 seconds. So in all total, we are getting how much? 5 seconds of delay. Okay, and then whatever the switch needs to happen, that will happen. Okay, now why 5 seconds of delay is taken? See, the decision of taking this 5 seconds or decision of taking this default values were, if you lower this down, the value would be anywhere between 2 to 4 seconds, right? Which is okay if you look into the full picture, but then if you look over here, this 2.5 will become 1.25. Okay, now every 1.25 second check will create a lot of performance issues in your network. Okay, so that is why every second there should not be a check, every half second there should not be a check. It has to basically ensure that your failures, if you are saying just by 2 checks, 2 checks is 0.1 second. 0.1 second again is not a good number to have. Why? See, what happens is, if you're if you're let's say for example this is 3, so 503 is 5 sorry 50 1500 ms, which gets equals to 1.5 seconds. If you do this, what will happen is there will be network flapping, because if the network comes up and goes down, and then you have 5 checks over here or 3 checks over here, it will very instantly revert and then come back, then revert, then come back, then revert, then come back. So it will basically it will create flapping in the network, and then your purpose will be defeated of having the SD-WAN, right? So you should not do this. It should always just try to see if you can follow this, the default. If it is the default, great. And if you have to change, then probably I'll say take the tax suggestion. Okay, do not just go just by your own guts, not do that. Take tax suggestion according to your networking situation, take up that. Otherwise the default behaviors, default values are good. All right. So if you click on OK now, you see this? Now it is in red. Do you know why? See, the SLA target is 5 ms. You are on 90 ms. Of course, it is red. So basically, in a way, this is saying that I will not accept this. Okay, but it will. It has to accept. The reason is because you do not have a port 2. So, I mean, if you look into it from a logic perspective, one interface is down and one interface is a little slower but active. So rather than dropping the whole traffic altogether, at least forward it to some interface so that even if it is slow, at least the traffic is moving, right? Doesn't make sense or not? Yeah. So that is what it basically tells, that even though I do not, I mean, port 2 is down, so I have just one interface. So I know and I understand that it is failing the target, but I'll still forward the traffic because that's the only option I have as of now. Okay. All right. Okay. So let me show you if I have to do this from the command line, how would you do this? So you say diagnose system SD-WAN and check. Enter. Okay. Now see, for port 2, there is a 100% packet loss, which makes sense, of course, because the interface does not have any routing and anything at all. Just it has been connectivity. That's it. So we'll fix this in some time. And port 1 is alive. Okay, packet loss 0, latency 93 seconds, jitter is 4. Okay, now SLA map 0. Okay, so SLA map basically means 0x0, basically means that is it matching or is it approval? I mean, is it being approved by the SLA or not? Okay, so same information but from the CLI diagnosis SD-WAN health check. Okay, next. See, as of now, it is not giving you any dashboard information because I'm not basically accessing anything, right? So we do not have anything right now. So let me show you. So if you have user PC2, right? So over here and let's ping 1.1.1.1. Can I ping? Yes. Um, what is the contents ping for? Can you see anybody? Can you see anybody? Data side by CMP station port source code. Okay, T. Okay, so T triple nine. Where are option? Why? Oh, sorry. There you go. Okay. So now what's happening is it will basically execute till 999 packets. Okay. So there will be in all total of 999 packets that you will be seeing. So you see the sequence value. This will be 999 and then it will close. Okay. Why am I showing you this? Let me tell you. So I'll take a capture diagnose network packet any, and this time the filter will be host. What IP am I using? 1.1. Okay. 1.1.1.1 close 40 L. Okay. So I'll close this now. Okay. Now just have a look. We know this that the traffic is coming from port 3, 32.5 going to 1.1, and now it is going with port 1 and it is going out and it is using source NAT of 192.168.0.6, which is my port 1. Clear all of you? Is this clear? Pretty much simple and straightforward, which we have already done so many times in the past, right? Now I want to show you that it will automatically switch from port 1 to port 2. Okay. Now, but before we do that, okay, I'll show you one thing more. See, as of now, hold on. So I'll go into the SD-WAN performance SLA. Okay. Now see over here, you have the 91 ms of the latency happening. Okay, but my port 2 is down. So let's first of all fix the port 2 that we have. So What do we need to fix? Port 2 is connected. Port 2 is connected. I can ping it. But if somebody is trying to, send a connection from port 2, it will not work. Okay. But question comes up, how will I know if the connection is going to your port 2 or not? See, in the performance, or let me show. So SD-WAN, ISP2 and ISP1, do you see this? Right? So ISP, and I'm having a performance SLA, which is also connecting with the ISP2, meaning I'm using ISP1 and ISP2 for a performance SLA to make sure my port 1 and port 2, which one is a better port. But port 2 is being shown down because there is no, I am not able to reach 4.2 from port 2. Okay. Now I'll show you this first of all. Um, 4.2.2.2. Okay. See, traffic from port 2 is going out with the 10.22, which is the IP of the interface. Okay. But do you see any traffic coming inside from port 2? No, it is just out. Means it is just sending the traffic out. But from port 1, the traffic is going out, plus there is the reply as well. So there is an echo request and reply, right? This is basically your SLA, what we are doing, what the performance SLA that we have configured, right? So that is your SLA right here. Okay, and I was able to see this information by this packet capture, right? So point over here is that this is how the FortiGate firewall knows that, okay, my port 2 is dead because I'm not getting any response. Clear all of you? Yes or no? Now let's make sure, let's configure the port 2 so that it starts to get responses. How do we do that? Let's see. Okay, coming over here. We get sound. So we have the IP of 10.23, right? So we have this interface. Now let's create a policy. The reason that traffic is not getting forwarded from the Fortigate South, a port 2 of the Fortigate South towards port 1 is because it does not have a firewall policy. Hence, the traffic is not getting forwarded. It is getting dropped. Okay. Now just to show you the packet flow, what we did was we were able to see this information on Fortigate North, right? I'll show you the same information over here. Diagnose sniffer packet any ICMP 40L. That's it. Okay, now do you see this? The traffic is coming on port 2 with 10.22, that's the IP address for 4.2, but it's not going anywhere. And it's, if you look from the firewall perspective, it's pretty simple and straightforward that we have to create a firewall policy here. And then as soon as we do this, our Fortigate South, which is acting as an ISP2, will be complete. So the traffic is coming from port 2 going towards port 1, and we are using all four over here. That's what ISP people do, by the way. Okay, so do this, done, click on OK, and there you go. All right, now if I refresh this 0 will become, yeah, see, there you go, see, 648. Now if I refresh this again this number will increase to 20.2 KBs. Okay, chalo, let's confirm this from the KB sniffer as well, and there you go. See, going out, coming in, going out, coming in, right? So now the communication has started to work. So our ISP 2.29 KB, let me refresh. There you go. See, working perfectly fine. Now if I go into Fortigate North, okay, if I go into performance SLA, till now we were able to see that port 2 was down. Now we will see that port 2 is up. Here, there you go. See, we do have packet losses. Now the reason is because I mean, we just created a policy. So before that, everything was a loss, right? So anyways, point is, this is having 100 ms. Of course, it will have 100 ms. See, reason, just think about it. Direct connection to the ISP and indirect connection to the ISP, right? So it has, there's one additional device through which the traffic is going. So as in many additional devices comes into the picture, the slowness will start to come. Okay, that's why. So we have this 100 value. Can I refresh this somewhere? No. Yeah, a little bit difference, but we can still see that the 1 and 2, both of them are working now. Okay, now let's quickly understand how is this whole setup working over here. um, PC2. See, there are, so we are around 600. So anyway, it by 300 more packets, it will go. It will be gone. So what I'll do is I'll quickly go into the network section. Okay. Now we have port 1 working and we have port 2 working. Now, if I, disable port 1, okay, what will happen is I'll lose the connectivity because I'm connected to with port 1. Okay. Because we have 0.6 and 0.6, right? So I'll lose the connection, but this should work for me, right? Let's see. Let's see what happens. Disabled, right? So I'll slowly this, yeah, say, yeah, so I'm pretty sure it's gone, and there you go. Oh great, so my connection is still working. Now how will you check? How will we check? Simple. Take a packet capture, and when password diagnosed if packet any, and I'll say host 1.1.1.1. See, I'm not using ICMP because if I use ICMP, it will also show me packets for 4.2, which is for SLA. I do not want that. I just want to see packet for 1.1. That's fine. 40, and that's it. See this? Traffic is coming from port 3, going from port 2 out. Make sense, all of you? Yes or no? Right? So in a way, what is happening is your load balancing is working. Okay. Now this is the default way of making it work. Let me show you over here as well. There you go. Going to, sorry, yeah, this is 1.1. Okay, so what is happening is that your ISP1, I am pretty sure this is not working, so it will not come up. So let me enable the Fortigate interface, config system interface, edit port 1, set status. Oh, sorry, enable, up, down. It is still not loading up, so I know that this has not worked, but let's try again. Now this should come up. In the meantime, see, worked for me. So, and it is using 7 ports. So chalo, let's quickly check what has happened. Is it still using my same port 2 or is it using a different port? See, it is still using the same port. Do you know why? Do you know why? Get system session list. That's why. Because it is already in your session table. Okay. Since the traffic is already in the session table, that's why it's taking port 2. Otherwise, it has started taking port 1. Now coming back to SD-WAN. See, as of now, what was happening was it was the default rule which was processing your traffic. What I mean is, just like in the firewall policy, we have a an implicit deny, right? What basically implicit deny means is that if there is no policy which is matching, the traffic will be denied. That is implicit deny. Implicit deny is if nothing matches, this will match. That is implicit deny, right? In the same concept or in the same analogy, you have something which is called as implicit allow. Okay, this is basically allowing everything. Why? Because see, the traffic scanning or inspection or malicious content, whatever that needs to happen, that has to happen on the firewall level, on the firewall policy level. Scanning of all the policy has to be done over here. But when you are creating an SD-WAN rule, it has to be an implicit allow. Why? Because you are just trying to forward the traffic, load balance the traffic. That is it. Okay, there's no blocking that needs to be done. If there is any blocking that needs to be done, it has to be done on the firewall policy level, not over here, because you are moving one step ahead. Now you are moving one step ahead from the firewall policy. Okay, firewall policy is like a restriction gate which needs to filter the traffic. SD-WAN is more like which interface do I need to select, because your approvals are all done. Your approvals of the traffic and everything is all done. You just need to confirm that which interface to select. So as of now, implicit all is basically making sure that all your traffic is whatever the source IP is. On the basis of that, you're making a decision. So let's create a new one. I'll create a new rule, and I'll say this rule is for 8.8.8.8. Okay, and I say if the guy is coming with 32.5 IP address, you can also use groups as in authentication. You can use that as well. Okay, so quite granular approach you can go over here. Then you have the destination, and I say 8.8, right? So I have to create, I have to create 8.8. 8.8, copy, paste it over here, /32, done. There you go. I'll select this now. Okay, so it says, do you want to specifically go with the TCP and specific port as well? I mean, it's quite detailed, to be very honest. UDP, or you want to use just the IP address, filtering on the IP address, and port can be anything. Okay, so you can specify as well if in case it's a custom business application, it is using a different type of service, you can use that as well. So we'll use the any for now. Internet service not required because we are using any. Okay, so this is not required. Now over here, the strategy on how the outgoing interface will be chosen. See, the best quality means on the basis of your SLA, the decision will be made. Manual is pretty simple. You just select whatever interface that you want. Lowest cost is on the basis of what the lowest cost from the SLA comes up, and maximum bandwidth. So again, depends on your SLA, it will take up that. Okay, so we'll take the best quality, and you know what, let's I mean, this will not work because of the evaluation, but let's take manual, and then I say use port 2. If anybody is basically using 8. If 32.5 is coming and is trying to go to 8.8, use port 2. Okay, enable and click on OK. Right, so now I'm saying ISP2. Okay, let's see if this works. Let's see. Oh, it's still working. Why should I miss? Ignore that. So we'll keep on pinging, but sorry, I have to change the 8.8.8.8. Okay, ping, it is working. So now I'll refresh. Do you see this hit count? It's as of now, it doesn't have anything, it's blank. You'll see something over here. There you go. See this? 9 packets. So in a way, what is happening is that your rule, your SD-WAN rule is getting implemented, and it is basically taking which port? Port number 2. How do we confirm this? Again, let's come over here. In the Fortigate North, you take diagnose sniffer packet any, and I say host 8.8.8.8, right? That's the IP 40 help. There you go. Port 3, port 2. Now, if I have to ping, let's say 1. Okay, let's take capture again on the Fortigate North. Maybe because the session is still session list. Let's see. Let's hold on. Do we see now? This is also a problem. Do you see this? So many packets. So many packets, and this will have, this is a genuine problem, it's a real situation. So what you do is, in real environments this will also happen. So you do a grep, and I just want to see 1.1.1.1. Okay, enter, and there you go. So 32.5, 4.2, 1.1, and it's taking 10.10. You see this? That's why you have such a, I mean, that's why you are not able to get to the port one. So what you do is you clear this off. How do we clear this off? Remember last time, diagnose system session filter source 170, sorry, let's take destination. Okay, so destination, and I say 1.1.1.1. Okay, done. And diagnose system session list. You see how many packets? My god, 59. So let's clear this off. Yeah, okay. Couple of times more just to be sure, and that's it. Still two packets coming in, because you have the continuous ping going on, right? That's it. But look over here this time, that which interface is it taking? It's still taking 10.2. Now 10.2 is my interface 2, right? So it is still taking that. So let's figure out why is that happening. We do know that your port 2 is being used. Okay, my port 2 is being used, and my SD-WAN rule says that if the traffic is going for 8.38, it should go with port 2. But if it is 1.1, okay, it should take something else. But you know what is happening? What's happening is, because this rule is creating a problem. Now see this spillover. Do you see this? So you can see the ingress spillovers. If I, so this is in kbps. Can I change this? No. So so if it, so let's say for example I say 800 kbps. Okay, this is the spillover. So as soon as the traffic reaches 800 kbps, it will be switched to the other one. Okay. Now sessions, this is more like a percentage basis. So if you say I want 80% of the traffic to be over here, okay, and then you say 20 over here, so 80-20, okay, or 70-30, whatever it is, okay. Source and destination IP. Let's take this. I think this should work. Why? Because see, source and destination over here I have 1.1, right? In the user PC2 we have 1.1. So let me first do one thing. Let me clear this off again. Diagnose system session list, and we have lovely 54. So let's clear this off. Clear. Couple of more times. Yeah. List 0. Great. Okay. So now let's do one thing. I'll start the pinging. Let's see what happens. Diagnose sniffer packet any, and host 1.1.1.1. Close this up for 5 packets and L. And there you go. Is it clear to all of you? Yes or no? Okay. See, this is what I was trying to tell you over here. Oh God. Okay. So anyways, my point is that you remember the last capture when we took, it was showing up as port 2. Why? Because it was taking source IP based. This implicit statement was on the basis of source IP. So my 172.16.32.5, that was the IP which was coming, okay, and the traffic was going with port 2. All right, and the rule says that just on the basis of the source IP you have to take a decision, right? So that is why it was coming up like this. Now when I remove this implicit statement from source to destination, so basically I have to check the source plus the destination and then take up a decision. Then it started to use port 1. Okay, so again, when it comes to the SD-WAN and the rules, you have to play a lot. You have to play around with a lot of options. Okay, create 3, 4, 5 rules and see what is happening. Use the lowest cost, the maximum bandwidth, and see what is happening. Okay, but yeah, it does need a lot of practice, and it does need a lot of situations and scenarios. Okay, now when I say situations and scenario, you just need to play around with these options. Okay, I mean, it's not that you have to have specific situation or scenario. Take best quality, take lowest cost, take multiple maximize bandwidth, take manual. Okay, take different source, take different destination. Okay, and every destination, create 8.8, create 1.1, 4.2, or any other IP address, and try to ping that. Okay, have 4 connections, 5 connections, 4 or 5 rules over here. Okay, and then use different PCs and see what is happening. The reason why I wanted to show you this is because if you understand the packet flow, which why it is taking port 3, why is it taking port 1, when it is taking port 2, what happens when you disable the traffic, disable the packet, and what is happening. See, anyway, whatever happens, you saw one thing. In any situation or any scenario, whether the configuration was right, whether the configuration was wrong, your traffic was not getting dropped anywhere at all, right? And that's what matters when it comes to the SD-WAN. SD-WAN is all about load balancing the traffic in such a manner so that whenever the traffic is being sent over or being forwarded from the firewall, it should take one of the interface and then it should get forwarded. Now, on the basis of what rules you have, you can always change those. But point is, the traffic should never be dropped just because of misconfigurations. That's the whole point. Okay. So guys, let's do one thing. Let's just pause for a couple of minutes. Let's take a couple of questions, okay? Because I do know you'll be having a lot of questions, right? So let's take those questions and then we move forward. Okay.